Hello, everyone. Welcome to another episode of The Circuit. I am Ben Bajarin.
Greetings, programs. I'm Jay Goldberg.
All sorts of interesting things keep happening as we near summer. There's many events going on, from people speaking at investor conferences, everybody wanting to talk about AI. We've had the continual run since the last time we talked about NVIDIA and their historic guide. Um, but there's an interesting debate that I don't know if everybody in our listeners understand around the data center and semiconductors. And this point is actually another similar point about client and future, but right now it's relative to the data center. Whether or not the AI lift or the AI chips is an additive, so a additional growth TAM to data center, or whether it's going to take away dollars from other segments. Meaning, will they not spend on their traditional cloud processors and instead focus on GPUs or AI? So that's a debate. I'm just going to kind of lob it out to you, Jay, for your first take. Is AI additive or accretive to data center TAM, or is it going to take away from other sections of the annual semiconductor spend?
My thinking on this has changed a lot in last week, really. My initial take was it's not going to it can't be additive, right? Because there's only so many capex dollars out there, and CFOs are only going to be willing to spend so much for AI. But I've changed that. I think it's a cycle, and I think what's going to happen in the immediate term, there's not a lot of change, right? I think because it just these all the data center in particular is on long budgeting cycles. It takes a long
Mm-hmm.
time to build a data center.
Mm-hmm.
I don't think anything's going to change immediately. I also think everybody's still trying to figure out what their plan is. And by everybody, I mean the hyperscalers. But I do think that over the next year plus, it will be additive. There will be a lot more semiconductor spend around AI, in addition to what everyone else is going to do, because they have to run their businesses in addition to planning for this great, brave AI future. So Google and Facebook have to keep doing search and social media. Uh, Plus, they have to do AI to to catch up or to get ahead or maintain their position, whatever you want to frame it as. So I think soon we'll start to see additive dollars, and then eventually that will taper off. It'll be a big sort of hump, and then it will taper off and sort of blend with the rest of the spend. Um,
Mm-hmm.
but I do think in the near term, people are going to have to spend a lot on all things AI.
Yeah, I agree. I've always believed that it's additive. I think where I think the challenge to this additive spend is everybody that you hear doing these massive deployments or research projects or trying to buy thousands of H100s is clearly trying to make sure they're not left behind. And my concern with this kind of initial bubble, because I've seen, and you've seen a number of the same reports as me, that a lot of financial modeling for this is modeling a sustained growth period through the next 5 years. And I look at this like, if a company makes that spend year one, year two, and then monetizes it, meaning that they either see direct value growth to their business or they're able to charge their customers to make money, then they'll keep making money. I mean, they'll keep spending on those solutions. But we don't know if that's what's going to happen. It could be exactly what you said, which is and the life cycle of a data center from everybody that we can gauge is somewhere between 5 and 6 years. And so you look at that and say, okay, well, it's not like it's all of a sudden going to be 3 years unless people are just making hand and fist money as a software company on this technology. So they're essentially going to look at this as a role, right? In terms of the hyperscalers, right? How many instances they add now, they might roll over until it's all the instances in 2 or 3 years of a conversion. But I do think we run the risk of this being a big spend up front and then maybe some tip off if, again, unless people are just everybody's making money hand over fist, which we don't know. It could happen, but if that doesn't happen, it's an initial cycle, like you said, and then we're sort of back to cyclicality, right? Instead of a sustained 5-year growth period.
Yeah, I think that's right. I mean, if you think about it, when we first talked about AI, what, 10 episodes ago, my take was we still don't know exactly what we're going to do with all this. There's right there's the consumer use case is still very unclear for a lot of generative AI. I think everybody agrees there's something there. There's a lot of exciting technology, but how are people going to monetize it is still unclear in a lot of sectors. Like, yeah, if you're doing content marketing, it's very obvious, but in
Mm.
a lot of these other areas, I think the use cases are still super unexplored. Um, right? And you think about NVIDIA's analyst event, the developer event, DTC, what was it, a month ago, 2 months ago, where they just had so many different use cases, right? NVIDIA AI in healthcare and energy and transportation and industrial. And I don't think anyone really knows what that means yet. And so as those develop, that's really what's going to determine the long term spending
Yep.
pattern. Right. I mean,
Yep.
obviously in the near term, Nvidia is doing fantastic numbers, but I
Yep.
think there's
Yep.
a broader story, and I think that's kind of what we're getting at is what's in it for everybody else. And I think
Yep.
there is a big opportunity for companies not named Nvidia, but that will take time to emerge. And I think what will ultimately happen is going to be a big shift in share of wallet around heterogeneous compute. And this is something you and I have talked about a lot, which is what's the future for CPUs? Like ultimately, do we start selling fewer CPUs because there's so much money going to GPUs? I think
Yeah.
in the near term, it doesn't matter. We're going to sell a lot of both, but over
Yeah.
time, those trends are going to be really important for quite a few companies.
Right. No, you're exactly right, which sort of leads to this follow up point. I've been talking to a few friends who do AI software, machine learning software training, etc. And one of the things that they've pointed out, and this is consistent across multiple people that I've talked to, is this stage that we're in right now, and I think again it's because it's early, whether it sustains, is these are very complex workloads. Is kind of the way they keep talking about this. It's just a lot of complication in your process and in your flow and in everything you do from training to inference. It's a complex workload. Now we sit at this junction, which is, well, do complex workloads benefit from a single compute solution like a GPA, for example, or that can do general purpose technology, or does it benefit from more heterogeneity when it's in this cycle? And to some degree, I don't know if we know, but I think that being fleshed out will talk a lot about who's best positioned, assuming that these workflows don't become less complex over time, which they might as technology evolves. But for the foreseeable future, very very complex workflows. Um, and that's what I'll be curious to play, because right now they're just like it's just easier to do everything on the GPA, and that's fine. Is that a
Uh,
truth that stands forever, or is it a short term truth?
yeah, I mean, I absolutely think that this will be more than just a GPU story, and it'll be more than just an NVIDIA GPU story. They will be the leader, and they will have a very strong position, but it has to be everyone else. I think for the economics of this to work out, we're going to have to do an awful lot of AI inference at the edge on the device rather
Right.
than in the cloud. I just it's hard for me to see everybody using GPT, ChatGPT, and other generative systems with all of that workload being done in the cloud. A lot of it is going to have to move to the edge,
Yep.
and I also think there's still a lot of it's going to end up on CPU, right? A lot of inference is going to end up on CPU just because of. I mean, certainly in the near term, NVIDIA GPUs cost so much and they're so hard to get. I don't see how you do all that. I'm sure that the TCO models, the total cost of ownership models, look pretty good in certain cases for doing generative AI inference on CPU.
Yeah. I think you're right. It's interesting that's not part of the conversation, which sort of leads me to the secondary topic here, which is right now when you look at the parts of silicon relative to AI that seem to get the most play, conversational play, is GPUs and AI ASICs, whether that's
Right.
custom silicon ASICs or just dedicated accelerators or AI ASICs. And so part of me, right, is I scratch my head for the same point that you said, which is that, well, we should be talking more about inference, even though memory plus CPU inference goes hand in hand. Everybody seems to be talking about the huge boost that's coming to GPAs or FPGA or GPUs and AI ASICs. And so I'm just curious, like, what do you, why do you think those two things get the vast majority of the play?
I think that's just because where we are in AI workloads, like for historically, which doesn't mean a lot in AI. The last few years, historically, we've done all of our AI math on GPUs, and there are good
Mm.
reasons for that. It's a highly parallelizable uh, computation that has to be done, suited really really well to GPUs, and because of CUDA, it and being able to play around at low level of the silicon that allows, that's meant NVIDIA. Um, so I think that's just where we're starting from that position, and plus we obviously have the example of NVIDIA's crazy numbers, but I don't I don't think people have really sussed out how the inference market is going to look. Right?
Yeah,
We can all agree training is going to stay with NVIDIA. Right? We're going
yeah,
to talk about
yeah.
AMD's event in a little bit. AMD just had a big event and they didn't really talk about training at all. Right? And if they're not talking about training, nobody else really has a shot at it. So training, let's just set that aside. That's going to be NVIDIA for the foreseeable future. Then we have to look at inference, break down that market. It's really two things. It's cloud inference and edge inference. And I think the dynamics in those two segments are going to be really different. The cloud inference is largely about hyperscalers and what they're going to do. And from what I can tell, they're all trying to figure it out themselves, and they're all trying to do the math and figure out how much of this is GPU, how much is AI accelerator of some sort, and then how much is CPU. And I'm not convinced any of them have solved those equations yet. Even Microsoft, who seems pretty far ahead in all this, hasn't totally sussed it out. But that's going to be the fight. It's going to be the those three components in some mix in the data center in the cloud.
Hmm.
Inference at the
So
edge is going to be a huge market. Like I said, I think a lot of this has to be done. That's even more complicated to figure out because it's so many different devices. And I think the this market is I know a lot of people are talking about it. It's going to everyone says it's going to be huge. It's going to be the biggest. I'm not convinced actually that there's going to be a lot of incremental spend there. Data
hmm.
center inference, absolutely additive, huge market. But for edge inference, I think it's going to be really challenging because the the places on the chips where you're going to want to do that, those sockets are already owned by pretty tightly, right? Smartphone, it's going to be Apple and Qualcomm and MediaTek, right? And there's not a lot of room in the phone for having a third somebody else come in and have a dedicated AI accelerator in a phone. That's going to be one of the existing vendors, and they're going to struggle to monetize it. Qualcomm and MediaTek in particular, I think, are going to really struggle to monetize that because how do you charge? How do you charge a customer for AI? That should just be a feature. It's
Exactly.
not it's
Yeah.
not a product,
Right.
right? And so I've written about this a bunch, where it's just like there's edge inference is a feature in another product, while cloud inference is a whole new product category, and that means really different monetization paths for those companies.
Yep. All right. So let's jump to the AMD event. So it's important, I think, to at least an interesting observation that everybody I've heard talking about this market that we're talking about sort of says who's going to benefit from AI? It's Nvidia and then possibly AMD. Most likely AMD, but possibly AMD. But AMD had a really good event. They launched a bunch of stuff, which we should talk about. But I'll let you start with just a couple highlights, takeaways from the event from your side.
So I would say that overall highlight is that they continue to execute very well, right? They have a great CEO, Lisa Su, probably one of the best top 3 CEOs in semis today, and they are just executing solidly as they have for as long as she's been in charge. They have all these new products. They're touching on all the different corners, existing products, new products, sort of product lines. I mean, right? I thought they looked really formidable on that front. They have answers. They had solid answers to all the questions. All that's they look really well positioned. So of course the stock fell 5% that day, right? Because I don't know exactly why. I think some of it was buy the rumor, sell the news, and so people sort of saw what they expected and said, all right, that's good enough, and they got out. I think a few people I talked to at the event, a few investors I talked to in the event, had hoped to see more specific
Mm.
customer announcements around some of these AI products. But at some point, I mean, they had what they have: Microsoft,
Amazon,
Meta,
Meta. Yeah.
Amazon, Hugging Face, PyTorch. I mean, like all these very serious companies show up and give testimony to AMD's products. So I think they did really well on that front. But I do think at the same time, investors are perhaps justifiably concerned how much of this market can they really peel away. Right? We know they're good at CPUs. We know they're continuing to gain share in the data center. They're fighting it out with Intel and client. So that's all sort of status quo. What's incremental here is around AI, and I think most investors just are now assuming that AI is 100% NVIDIA.
Mm. So I agree. I think to your point about, they talked about training, but definitely not as much as I think people wanted them to talk about training. I think if they would have had a super strong story, product lineup, defensible position where it was clear that, yep, you're gonna supplement Nvidia and take share from Nvidia, I think that would have helped a lot. I know from some of our NDA conversations, which you can't talk about, there was some posture of confidence that that there would be some maturity in their GPU roadmap and software that would start to position itself accordingly against Nvidia. But we don't know. We'll wait and see. Um, there was one product though that I thought was interesting, and I make this point from an architectural standpoint, which is, they announced their MI300 at CES, and everybody was pretty excited about that. And then they just launched a version of that, which is the MI300X, which is specifically built for machine learning models. And what I find fascinating about this was they took their chiplet approach in the MI300 and basically swapped out some components and put in new components dedicated to this MI300X for machine learning. And it's this modular benefit of chiplet approach that I think is truly fascinating, because it basically suggests, and this was kind of my takeaway and my highlight, which is a technical one, but it basically suggests that when you take this chiplet approach and you have a very modular design to your roadmap, you actually have a bit more of a dynamic and fluid roadmap than back in the days of monolithic, where you were, looking 3-4 years out decisions today of your core, and once they were stuck, you couldn't really change them. And so the fact that on a relatively quick timeline, in AMD was able to say, we see an opportunity, we have a flexible and adaptable architecture that we can modularly swap out a piece of that component, put in another one, and go target a market, I thought was really fascinating. Whether that's, a huge hit, there has been a lot of, I think, positive sentiment of the MI300 line. But from a technical standpoint of roadmap, I think this modular approach is actually a really fascinating one from a semiconductor standpoint.
Oh yeah, absolutely. Their chiplets, their modular, I think it's the right way to put it. Their modular approach is really, really fascinating. Just technically, the way they're able to mix and match is it's people have talked about chiplets for a while. I think there's a lot of excitement among certain people for chiplets. I think AMD is really the I don't want to say the only, but clearly the best and one of the few that can actually like make it happen, and is doing some really fascinating things with it. Using having one chip that has different processes on it, different manufacturing processes,
Yeah.
all sort of communicating together is technically really hard, and they're doing they're using it to its
Yeah.
utmost.
Yeah. Yeah. Mind blowing too to think about. I'm not a electrical engineer, and I don't know how these things are done, but just even the mind blowing way it gets made on these tiles or made on different processes. Anyway, it just to me it made me very intrigued with the way that AMD can adapt its roadmap for different segments of the market, and just decide how they want to configure these things that they feel will give them the most value. So technically, I thought that was interesting. The other part that I thought was interesting was really starting to target what a classification of the data center that they call cloud native. And so that is your traditional e-commerce web loads, your streaming services, just stuff that runs in the cloud. And they have a whole series now of products designed to go after these solutions that focus on performance, but also performance per watt, handling all of the workloads that's necessary in sort of these cloud web applications that run online, but also trying to do so with less rack space, thus requiring less power, so less of a footprint by a hyperscaler or a cloud service provider, less energy per rack. And I thought it was interesting because to some degree, this is an attempt to encroach at the value position of some of the ARM based CPU designs, Ampere being one, but also Graviton, and Amazon's not, or AMD's not going to say that since Graviton, Amazon's a customer, but the value proposition of what ARM was trying to come to, it was interesting that AMZ said, look, we got a lineup that speaks directly to that value proposition in this cloud native application area.
Yeah, I caught that too because cloud native is a term that I think Ampere has used pretty strongly in their marketing position, their marketing materials, and here was AMD also using that terminology. And I mean, this goes back to when I was at Qualcomm and we were trying to sell server CPUs. The amount of variability inside of the different data center workloads is pretty significant.
Mm,
There are some workloads that are just never going to fit on ARM, right? We sort of just knew that, and so they're just going to have to be run on x86. But there are lots of others that run today. I would say run better on ARM than they do on x86, and it takes a lot of planning to sort of figure that out. But we definitely see that in the hyperscalers purchasing plans. They know what workloads are going to assign to different things. It's not. I think most people who aren't in the market sort of just assume they're just going to buy a bunch of CPUs and plug them in and run everything on them. But there's a lot more planning and fine tuning and getting matching applications to certain things, and that's a really important part of how you sell to those customers is being able
right.
to say this is the product for just basic web serving. This is the product for streaming. This is the product for search queries, right? And this is the product
Yep.
for social media graph plotting. Um, and so it's interesting to see AMD using their chiplets and their modular approach to go after that, and just being able to reflect that in their marketing is pretty solid. It's a pretty good
Yeah.
idea.
Yeah, and I think it really just is this emphasis on, we talk about performance per watt a lot on client devices, but over the last couple of years, you've noted that the narrative toward data center has also been toward performance per watt to the degree that they've leaned on that for HPC, high performance workloads or AI workloads, which are not going to be perform, a low power demand. These products are relatively standardized in the web, um, workflows that they run for software companies, databases, JavaScript, etc. So it makes sense that that's an approach where they're focusing more on performance per watt, but you're hearing them say it more, right? That this is the area where high performance at lower wattage matters because we want less racks, we want less energy, we want you to save those costs. And so I thought that segmentation was good. I think again you're right in that it there are a lot of stuff I think that run well on ARM. I think the key is going to be who can do it. And I guess I'd be curious on your point. I think the TCO story is now the one that comes into play. Everybody's strategy. That's Ampere's story now. Is not just performance per watt. They have that, but can I do this? Can I do the same workloads with less chips and less energy? And that's the battlefield Intel, AMD, and Ampere, I think, are going to fight out for, let's just call it, this cloud native category.
Yeah, the biggest constraint on data centers on the cloud is power.
Yeah.
You build a new data center, you have a power budget, right? Even before you have a dollar budget, you have a power budget. You only have so many whatever kilowatts, gigawatts, was it megawatts you can use, and you design around that. And that's the key constraint. And yeah, you'll stretch it here and there because 20% of your workloads have to be super high power,
Yep.
applications running. But that's the you by doing that you're going to give up somewhere else, and so you have to switch to a lower power for something else. And I, modeling that is not easy. I think they spent a lot of time thinking through all those things, and they probably could don't even know. It's probably as much art as science. But that's the real constraint: is how much power we have. Let's figure out everything else based on that. And so it makes sense. I mean, this TCO is now the main point of conversation because that's what customers are really. That's how they buy things. They buy things with TCO models. They have really really complicated TCO models, and they look at not just the cost of the chip, but also the server, and then particularly the power. Power is a huge
Yeah.
component of all this
Yep.
for running everything, and then cooling it down. I mean, cooling is probably as big a power usage as just running the server itself.
Yeah, no, totally agree, and I really do think, because you and I were talking about this TCO narrative at the event, you know, I feel like the that Ampere had a growing narrative on TCO for the last couple of years that Intel and AMD just didn't have the same story, and I think these products from AMD and ones that will be coming from Intel are clearly designed at that narrative that had been growing as the reason why so many people had been optimistic about ARM in the data center because it really did have a TCO value. And so I think this now has shown me for the first time, because I just didn't think last year's roadmap, both products, both from AMD and Intel, had that. They didn't have that same story that Ampere had. And I think now they're creeping into that sector, and now their story's stronger. This TCO story is stronger from AMD.
That's interesting to me because I come at it from the ARM side of things, from Qualcomm, where that was the story, was the TCO. And I think that's always been embedded in the ARM marketing angle. ARM and its ecosystem is right. There is that that sort of thinking in the industry that ARM is always going to be more power efficient, which isn't totally true. ARM is power efficient certainly in mobile, but as they've moved into the data center, they use that as a really powerful tool to say, hey, we get the same performance with half the power or whatever. And the ARM side it's interesting. They've been moving in a little bit of the other direction, increasing their power usage and sort of shrinking that advantage a little bit because they have to do that to get after
They have
some of the
to.
bigger
Yeah.
workloads. And so but it is telling that the x86 camp is now adopting the same language. They've had to respond because ARM has been fairly successful in making its inroads,
Yep.
and so it's not surprising that Intel and AMD are using that language too. They have to.
Yep. So interesting battle there on, and I do like, as much as I'm sure Ampere hates that AMD and others are using this cloud native term, it makes sense because there are cloud first applications, software applications, services. So it makes sense that you call them cloud native. So I'm not terribly worked up about us using that as a categorical name for that segment of product we're talking about, and then them starting to design products specifically for cloud native applications. I think that's okay. I like the distinction for it, but it's a separate battleground now that we have cloud native AI. I don't know what else we'd add to that, but you know what I mean? Like we're segmenting the data center in more ways than we had a few years ago.
Yeah, I mean, we have to. We all now have to talk about TCO because that's how the customers, the hyperscalers, actually make their purchase decisions. So it's important to understand TCO. And then I don't know if you noticed at one point, AMD threw up a slide about cloud native ecosystem, and it was just this incredible eye chart. It was like 100 different logos, like all mapped out. And
Yeah.
I gotta like study that because they've done exactly that. They've segmented it all out, and it is it's so complicated. It's so complicated.
Yeah. Well, it's interesting though. I mean, like I said, segmenting the data center is not brand new, but I think it shows the emerging and complexity, right, of all these workloads. The data center is taking on more workloads. AI is an example of that. People have been, obviously hosting video and all of their apps and web applications, etc. But it's segmenting more into a wider range of workflows. So I think that's interesting, but it makes sense that semiconductor companies have to target. They're saying, well, this is the segment I'm going after. This is the segment this product makes sense for. So, like I said, not a brand new dynamic, but it's definitely one that's growing. The segmentation in data center.
Well, I mean, going back to what we're talking about, the top of this episode was AI. I mean, you look at the power consumption of these AI systems; it's through
Yeah,
the roof. It's blowing everybody's power budget,
yeah,
and so and there's no easy way around it. And as much as we've been talking about AI being additive to capex and semiconductor spend in data center, it's it's very much a problem when it comes to power. And that I think that more than anything else is going to be able to hold things back. Well, that and availability of NVIDIA chips are going to be
yeah,
what holds back AI for a while now.
yeah. Totally agree. All right. Well, interesting times. We'll wrap this one, and I sure a topic that will come back relatively frequently too. But thanks for listening, everybody, and we will talk to you next time.
Thank you for listening. Tell your friends.